Alright, we want to find for what real value of x is this equation true. So you'll notice this is not a quadratic, this is a cubic because it's x to the 3. And how you solve these is by using something called factoring by grouping. So basically, look, you just take these first two terms, okay? And you take these last two terms. And what you want to do is you want to basically from both of these equations, you want to factor something out that will make the remainder equal. So, for example, let's see, what can we even factor out here? Here we can factor out an x squared term, right? So let's factor out x squared. So if we factor out x squared, we'll have remaining inside just x, right? X to the 3 divided by x squared is just x, minus 5. So 5x squared divided by x squared is just 5, right? So this is what you have remaining. So let's look over here. Is there anything that we can factor out of this to make the remainder look like this? Well, yeah, there is actually, right? We can factor out a 2, so watch. If we factor out a 2, what do we have remaining? Just x and then minus 5, right? So that's your goal with this. So when you pick the two terms, you try to factor something out to make the remainders the same. And once you're there, you have your two factors. The remainder is 1, so x minus 5, and the other is whatever you factored out here, plus or minus whatever you factored out here. So in this case, the other term, or other factor, is x squared plus 2 is equal to 0. This is how you factor that. And if you want, you can actually multiply this out, and you'll get this same thing back. So now that we've sort of factored it, we continue to solve it just like we would a regular quadratic. We just set each individual factor equal to 0. So that'll be x minus 5 equal to 0, and x squared plus 2 equal to 0. And another quick note, what you want to do is, so I'm looking here, I see that it's x squared. So before I continued, I just made sure, like, can I factor this further? No, I can't. Sometimes you'll be able to factor this one further because it'll be like a quadratic term. It'll be like a perfect square, and you can factor that further. But in this case, you can't. So we set our factors equal to 0. So here, x equals 5. Here you have x squared is equal to negative 2, right? Subtract 2 on both sides, and here we added 5 on both sides. So x squared equals 2. Like, take the square root of both sides, just x, right? Just x is equal to the square root of negative 2. Can we have that? No, that's an imaginary solution, right? So this is not a real solution. So our only real solution is x is equal to 5.